Okay, we are discussing this particular question, and you actually highlighted your interest in this question. I'm sure I'm going to suggest more questions for us to practice. Right. First things first, we have this one to do. How do we solve this one? To solve this one, first things first, we need to write x squared minus x minus 6, which is less or equal to 0. And then you need to factorize this here. The factors of x squared are x and x. The factors of 6 are actually 3 and 2, whose difference is minus 1. But because the middle term is negative, we need to associate a negative with the largest of the terms. And then now we can note the critical values. Right, I know that in the morning I did not spend time on the critical values, but the critical values of an inequality are the ones you obtain when you make it an equation, and they are exactly as shown there. And so now this one here is a quadratic, can be associated with a quadratic function with a minimum vertex. Which means that you have minus 2 and then 3 x, which means therefore at this point you have between minus 2 and 3. And so now if this is less or equal to 0, we're looking at the way it's negative. So it is negative over here. And if it is negative over there, is negative over there below the x-axis, and therefore you'd have a solution. The solution would be that this is negative when x is between minus 2 and 3, but since it's less or equal to here, you can just put less or equal to there, and we are done. Okay, now this is the easiest way to solve these quadratic inequalities. But there's another
Sir?
method. Yes, please.
So how do we know if it's a minimum or maximum vertex?
Yeah, it's because of the coefficient of the quadratic term. Because now if you compare it with ax squared plus bx plus c equals y for a quadratic function, you realize that if a is positive, yes, if a is strictly positive, because it can't be 0 for a quadratic function, because if a could be 0, then this x squared term will go away. If x squared goes away, then we have no quadratic function anymore. We would be having bx plus c, which is a straight line. So a must be positive or negative. Right, so if it is positive or negative, like in this case, a is 1. Okay, a1 means therefore we have a positive a, because 1 itself is positive. And if 1 is positive, then we have a minimum vertex. Okay, it goes against the expectation, because one would say a is 1 and therefore it's positive, it's big, then you would expect it to be maximum, but it becomes minimum. Okay, and so now with that, because the a is 1, so we know we have a minimum vertex. And now we can then put our critical values. So starting with the smallest one, because we are dealing with the number line here of the x values, starting with the smallest one, and then you put the biggest one. Now you then say equal to 0, you shade. If it's less, if it's strict, then you put open circles here. Okay, it's less or equal. Less means you are below, like this. Then it's less than 0. Right. Less, because this inequality is saying less. So we are below. If it's less, then you're below the x-axis. Okay, less means that this is less than 0. Less than 0, in mathematics, numbers less than 0 are negative numbers. So this kind of a graph you get in the case would have a situation where less than 0, where the graph is less than 0, then it's where the function is negative. The function is negative when it is below the what? Is below the x-axis. So when the function is negative, then, okay, we don't need to draw a complete graph. We just need to draw this shape. We don't put the y-axis here. Right, and then say, okay, it's negative, so it's below the x-axis. Between -2 and 3, it is below. And that's the answer. Okay,
So,
if it was,
if it said,
yeah,
so if it said that the equation is just smaller than 6 instead of saying bigger and equal to, I mean smaller and equal to, what would it be?
yeah, okay, it
The
could be x
solution?
squared minus x is less than 6, like this.
Yes, sir.
Right, so yeah, in that case, it would be x squared minus that minus 6 is less than 0. Okay, at this point, we would get our usual factors of x squared being x and x. Factors of 6 that give -1 when added or subtracted are 3 and 2. But obviously, because this one is negative, so you need to put a negative there. And then now you put the critical values. The critical values will be x equals 3, x equals minus 2. Okay, so because now the coefficient, you look at the A is 1, positive, minimum vertex. Because it's big, you can use the word big, it's bigger than 0, so it's big. And therefore the shape is going to be have a minimum vertex. You put your critical values -2, then 3. And then now, because it's less than 0, you must put, because it's strict, then you must put open circles there. Ideally, you can draw this x-axis, then, okay, if you have the time to do something smarter. Yeah, but you must have open circles. This is the x-axis, and the shape is going to be like that. But we're looking at where the shape is less than 0. Less than 0 means it's below, which means -2 is less than x, less than 3, below. So if it's -2 to 3, it means that when is the shape below, it's between -2 and 3 that the shape is below. Between -2 and 3 that the shape is below. So that's why we're saying, okay, but if it was x squared minus x minus 6 bigger than 0, if it was bigger than 0, what would the solution be? Being read from this shape, so you would realize bigger than 0 is when it's bigger than the x-axis or greater than the x-axis, above the x-axis. And when is it greater? So it's greater when it goes above the x-axis. When is it above the x-axis? When you go to the left of -2. So that would be x less than -2. Or this is greater than 0. Greater means you're looking at the things above. So that will be x bigger than 3. But obviously we say or here because greater it will be going to the left or going to the right. And there's no solution therefore in the middle, because the solution is going to be when it's greater than 0, only when it is above the x-axis, something like that. Okay, I mean, that is sort of the solution to the problem. And that would be the solution in the event that the examiner would change less than to greater than. Okay, but now there are tricky instances like the exam paper I was looking at earlier today. You might have a situation where the examiner now in that prelim paper, they just brought something like 16 minus x squared is greater equal to 0. Okay, something like that. Or strictly greater. Yeah, I think it might have been straight. Right, so is what I was looking at in the morning. Now, what is the graph of this? Okay, obviously there are two ways to do this. To do these kinds of problems, you can always make sure that if you obviously want to be on the safe side, always multiply every term by negative. If the x squared term is negative, multiply every term by negative. And this is x squared, you multiply it by negative, it's -16. You multiply it by negative, it's less than 0. Okay, I multiplied every term by negative. So if you multiply the left and the right by negative, the inequality changes direction. It was bigger than, now it's less than. And then obviously you need to factorize this. Okay, so what are the factors of this? So the factors are x and x. The factors of x squared are x, and then 4 and 4, minus plus. Okay, is the morning question I'm looking at. Right, so in which case, therefore, you realize that you'd have minus 4 and 4. Okay, sometimes you don't need to write a lot because IEB exams are very long. It's difficult to finish these exams. So you need to be very fast. Okay, you might not even have to write critical values. Yeah, you can see that x is minus 4 because they would want the shape. And then now x is minus 4 and x is 4. Then you then say, this is negative. Negative means it's below, but it's strict. Then you put open circles here and you can wave this one like this and then say, okay, this is the x-axis. And when is this less than 0? Less than 0, it's here. It's between minus 4 and 4. Okay, that's the answer. Now, this is not the only way to do the question. In particular, if the examiner brings something like this, the coefficient of the x squared term is negative. So obviously, at this point, this one is what came earlier. I was looking at the prelim paper, that's why I'm bringing this. But yeah, it has 2 terms only. It's quadratic, but it's not a trinomial like this one is a trinomial. It has 2 terms only. So you have 4 minus x into 4 plus x. Right, so your critical values would be, okay, it's going to then have a maximum vertex. Okay, this one is going to have maximum vertex because the coefficient of x squared is -1. A is -1. It means we have a maximum vertex. Okay, maximum vertex, or don't want to call it a vertex, the turning point, right? So the critical values, you don't need to write them a lot. So in the IEB exams, you have any exam, you have 4 minus 4 to start values of x. You can see them, so you write them here. And then now you then say is greater or equal to 0. When is this greater or equal to 0? Is greater or equal to 0? Equal to 0, you shade. If it's strict, then you put like the open circles. But here is greater, it's equal to 0 as well. So you need to shade greater above. You can even do this. So how do you write the answer to this? What is this graph saying? Graph in terms of an inequality. So you then say, okay, it's greater than 0. It's here. It's between -4 and 4. X lies between those. And you have this. And that is the answer. So those are the kinds of things. Right. So you can think of that. Maybe let me see if I can find another question from this paper. All right. Okay, you have this. What year was it? Okay, this is 2019. Please allow me to open another paper. Okay, I'm sorry that I'm opening another paper, but it would be this one. Is it 2016? Okay, I want to open a different question on this so that you can try that one. Make sure you just sort of get the correct answer. Okay, this is the wrong paper. Let me see. Okay, I'm opening wrong things here. Let me see this one. Okay. Okay, look, and I'm opening this paper. Discard this and I can open the other one. Okay. I thought I had 2016 here. Let me see. Oh, it's this one. Right. So, we open this one, 2016. Okay, here's 2016 paper. Now I'm just bringing this paper so that you can like pick from each paper, full screen. Okay, this 2016. I'm going to pick something. Try this one. Try A2. Yeah. You try A2. Okay, let me keep it here in the meantime. Right, try A2 because of inequality. You want to see what you're going to do. Okay, it's 5 marks because, yeah, it is a lot of marks. It's 2016. So, yeah, it was quite a hectic paper, this one. Um, so in mathematics, when you solve an equation first, okay, yeah, you're going to try this one, then you're going to mark it together. Now, when you solve a problem like this one, this is too easy, but the quickest way to do this, there are a couple of ways to do it. You can add the two, you can multiply by the LCD. Um, the easiest would be, and the most popular, you have the LCD 2 and 3, just multiply these two. The quickest way. Then you take this 2, you divide by 2 first, and you get 3 by that, which is 12x. We have this one divided by 3, which is 2, and then you have that is equal to 5. So which means it is 12x minus 4x minus 2. Okay, we have 5 by 6, 30. Okay, 8x is 32. Divide by 2 by 8 both sides. You have x is 4. That will be sort of the case. Okay, yeah. We can multiply by the um, LCD 2 by 3. That's yeah. And then multiply each term by 6. So multiply this one by 6, multiply that by 6, multiply that by 6. Okay, please try A2 quickly and let me know you're done. Maybe you're done already. Just need to, yeah, get a hint of the answer. It was a hectic paper.
I'm done, sir.
Okay, thank you. Yeah, what do you think is the answer?
So I got -2 is smaller or equal to x, or x is smaller and equal. Oh, -2 is bigger or equal to x. No, yes, -2 is smaller or equal to x, and then x is smaller or equal to 13.
What is it? Small equal to?
13.
Okay, that's fine. Anyway, I'm just interested in getting an idea of how well you can do this. But obviously now, if you have x minus 5, this one, look at A2. So you have x minus 6 is greater equal to 56. Right, so you need to first multiply this out. You just have no other way. X by x gives x squared minus 6x minus 5x plus 30 is just equal to 56. Okay. X squared, these two here will give us minus 11x. 30 minus 56, you don't waste time, is minus 26, is just equal to 0. And now you have this one to solve. The factors of 26 that give 11 are 13 and what? 13 and 2. Yes, 13 and 2. Right, and you put a negative there and a plus there. Right. So at this point, you'd have that this one is going to have a, because the coefficient of x squared is 1, so and 1 is bigger than 0, so it's going to have a minimum vertex. And then it's going to have minus 2, then 3. So we have that. So which means, therefore, um, you shade there, and then what are the answers? Minus 2, this is 13, please. So you have minus 2 is less equal to x less equal to 13. Yeah, so well done there. That would be the answer to the question. Okay, so I'll just testing with that one. Right, so let me see. The roots of a quadratic equation are given by determining the values of k for which the roots will be non-real. Max, the thought? Okay, give two values of c for, okay, we're doing E, please. Okay, give two values of c for which the roots of the equation are unequal and rational. Okay, so if you look at this one here is 3 minus x, 3 minus k. Right, the roots of the are given by these. I mean the values of k for which the roots are non-real. Okay, non-real, we just have to look at what is under the square root. If they say non-real or real, look at the square root and forget about everything else. And non-real would mean that you are making whatever is under the square root a negative number, because non-real numbers would be the square root of a negative number. 2i, non-real, technical math, technical mathematics. So we're good.
Sir,
Yes.
can there be questions where there's no square root and they're asking us to determine which values are non-real?
Well, they can't be. That's a good question. Yeah, you can show a case, but okay. Non-real roots would be there must be a square root, a fourth root. There must be an even root. Okay, because if it's cube root, like cube root of x, then you can have a negative here. So like if with the cube root of x, you can have -8. Not a problem. Right. So even if you got your calculator, the calculator will give you -2. For example, is the answer to this. Okay, but obviously now if it's a square root, -8 makes no sense because it's a square root. The reason it makes no sense, it means therefore that is when the only way when they can ask for non-real roots. But non-real roots, just need to make what is under whatever is under square root less than 0. Okay, and the only case I can imagine would be a division case. So like here, when is this vertical and horizontal asymptotes? Asymptotes have to do with undefined cases. What are the undefined cases? So like a vertical asymptote would be the x. There would be x plus 1 equals 0. Why? So want to find an asymptote, we equate the denominator to 0, in which case we get x equal to -1. All right. Um, um, so we have that. We continue. Um, all right. Yeah. So like write the equation of the vertical and horizontal asymptotes, undefined cases, the denominator would be 0. So we force it because we can't divide by 0 in mathematics. Quite division by 0 is problematic, but also division by 0 produces asymptotes. So now if we want to find the asymptotes, we force the denominator to become 0. We force division by 0, and therefore that gives x equal to -1, which becomes an asymptote because it's problematic to divide by 0. But also now obviously the two asymptotes for this one would be the usual rectangular hyperbola. This is the usual rectangular hyperbola, and therefore x equals to -1 and or y equals 2 are the values. Okay. Okay, so we're good. Right. Um, all right. Let's see. So you have that. Um, you have that. So we continue. Okay, yeah. I was just commenting. Yeah, yeah, it'll be interesting to um okay. Okay. All right. Any question? Okay, I'll try
No,
to.
sir.
Okay, yeah, but yeah, the root of the quadratic equation are given by this. Determine the values of k for which the root and unreal, which is given 2 marks. So you don't need to look at anything in this question except that you need to look at the square roots and then say 3 minus k is less than 0, and then you solve for k. So here the k has a negative before it, so the answer will be this. K is bigger than 3. Right. Right. Any question? Think about it, yeah. I go back to another paper because I just opened this paper. Okay, maybe I can go back to that paper again. Um, okay, like they brought this question here in question 2. Given this one, it has a square root. So it might have the idea of real solutions arises when we have square roots, you know? So you would say a student claims that a
Oh, so
solution,
I did this one.
please come again.
I did this question.
Oh, okay, that's fine. All right, what you suggest with other, should I go to another specific question?
No, so can we go back to the 2019
19
question
paper.
because
Okay, that's fine. Let's go back to the 2019 paper, this one here. Right, and we have exactly that. All right, yeah, this is the paper we're looking at. Um, think about, yeah, what other question would you like us to do?
so question 3, number A2.
Okay, 3A2, let's check. Right, let's look at 3A2. This one. Hence or otherwise determine the equation of the tangent at the point x equals 1. So obviously you need to first look at this one. F of x is minus 5x squared plus x. F of x is minus 5x squared plus what? Plus x. Minus 5x squared plus x. Right, so if you want to find the equation of the tangent, so you need to find the first derivative. Um, um, okay. Okay, we're gonna solve this one quickly, please. Right. So how do you solve this one? We find the derivative, which is that. Okay, the derivative now. 2 times minus 5 is minus 10 plus 1. So hence otherwise determine the equation of the tangent at that. So which means if primed at 1, right, so you have minus 10 plus 1, which is minus 9. Okay. So so we continue. Okay. Right. So this is the gradient. So if this is the gradient, we continue. Um, right, the equation of the tangent. So right. Um, um, okay, look at this. This is the slope. So you found the first derivative and then you substitute x by 1. Now, which means that you need to find x and y values. X is 1. So you have f of 1. Okay. Right, so we continue. Okay, if x, then you substitute here. So, which is minus 4. So, which means x is 1, y is minus 4, which means y minus y1 equals m into x minus x1. We continue, which means now to find the equation, you substitute this one is x1, y1. Y1 is going to be like a minus 4. The gradient m, which is the first derivative, is going to be minus 9. X minus x1. Okay. So you have minus 9 plus 9. which means y is the same as minus 9x plus 9 minus 4 minus 9x plus 5. Okay, so you need to ask yourself a couple of questions. Right? So yeah, so y is equal to minus 9x plus 5. So this is the equation of the tangent. Is this equation of the tangent correct? One way to check is when you substitute the x and the y. You substitute x, you must get y equal to minus 4. Okay? X is 1. So you put here minus 9 by 1, which is minus 9 plus 5. What is minus 9 plus 5? It is minus 4. So you get minus 4. Okay, so that becomes the answer. Hence or otherwise determine what did they say hence or otherwise? Why hence or otherwise? Well, hence would be that using an answer from above. So the answer from above would be this one here, the derivative. But otherwise, you can find the derivative. We found, in fact, in particular, in our case, I decided I'm not going to check the answer because we did not solve this one just now here from first principles. We just went straight to this one. So we just used the rules of differentiation to find the first derivative of this. Okay. So we continue.
Okay, so my next question is on B1.
B1, eh? This B, hey?
Yes, sir.
All right. Oh, B1, this one. All right. Right. So, right, to look at B1, you have to obviously find the derivative. Every time if they give you something that's complicated, break it down to pieces. So you need to break it down to pieces, which is x cubed over x plus x cubed over x. This is x squared plus x to the power 3 over 2 over x. So this is x squared. You break it down before you do anything. Okay, here, this one here is x to the power 3 over 2 minus 1. Right, so you have this plus x to the half. Okay, then you find the derivative of this. Right, which is dy dx. The derivative of the x squared now becomes 2x. The derivative of this one now becomes 1 half x to the half minus 1, which means it's dy dx is equal to 2x plus 1 half x to minus that. 2x plus x to the minus 1 half. So we continue. This is the answer. Normally, you must write your answer with positive exponents or positive indices. So you can see clearly therefore here that the the exponent was minus 1/2. We have moved it to the bottom so that it becomes a positive exponent. But also you can write this one as, guess what? You can also write it as like plus 1 out of 2 square root of x. It's also very much acceptable. So that becomes the answer. Okay, so that becomes
Um,
the answer.
okay, so my next question is on question 5, number
Okay,
I think number 5, question 5, number D.
okay, that's fine. Before I move to question 5D, this one, yeah, okay, it's 4. I'll just comment on this one I'm saying, okay? Obviously this looks way too easy. The answer, I believe it is, because, but it's terrifying in the way it has been written, because it's written with the exponent minus 1. And the way it can be done is 8 x cubed minus 27 divided by, okay, because the exponent is minus 1, you need to bring this to the bottom. I'm just commenting on this here. Plus 6x plus 9. Okay, because this is already done, because now you have brought it down to the bottom, it will have a positive exponent 1. Right, so when you get to this point, you need to deal with this. To deal with this, because obviously now you need to think of this and you need to simplify it. It has been given only obviously 3 marks, right? With respect to x, you need to simplify these. What are the factors of that, for example? So the factors of that would have to be what? Right. So there are a couple of ways to do this particular question. I can imagine you just need to simplify it. But as you simplify it, so this one can be written as 2x cubed, 3 cubed. Okay, that's why it makes it tricky. Now you need to, the only way is to simplify these. Right, and to simplify these now, you can write it like, what are the factors of these here? So it looks like the factors become 2x and 2x, right? 2x squared. And then can the denominator be factorized? So you need to look at whether the denominator can be factorized. Okay, just 1 second. So you factorize that denominator and then yeah, I'm just commenting on this one in passing. I know that, yeah, it's terrifying. It has lots of things, but you meant to simplify this, yeah, because they brought the power, minus 1 power here, and you therefore need to simplify. Okay, I left my pen. Okay, I'm going to bring my pen, my writing tool, so that what I'm writing is very clear. Just 1 second. Right, we have 4x squared plus 6x here plus 9. Right, so if you look at this one here, what do we get? Right, if you equate it to 0, what do we get? All right, so yeah, so the denominator cannot be factorized. It can't be factorized. So I just mentioned that. So yeah, you just need to factorize the cubic. Okay, let me bring my tool. Okay, I'm just commenting on this, but let me just erase this quickly. Right, let me erase the denominator. We cut this one, cut this one. All right, so you're gonna keep this one because this one cannot be factorized. Does not have real factors. Okay, there's no square root of, I'm mentioning real factors because if you use the formula, there's going to be a negative under the square root, right? Because if you look at the discriminant under the square root is b squared minus 4ac of the quadratic formula. And then now you're going to have 6 squared minus 4a is 4 and c is 9. In which case, you get the answer, which is 36 minus, this already is way up because it's 4 into 4 by 9 is already 36. So this is negative, meaning under the square root, we're going to have a problem. So we keep the denominator as it is. Okay, creative question from the examiner to just throw students off. Some students will try to factorize these. Okay, 2 factors, but if it's not going to work because, yeah. All right. What are the factors of this? So this one now, the student will have to remember that x cubed minus y cubed, I'm just mentioning this is passing. You cover the top because now it's a difference of 2 cubes. Difference of 2 cubes. Difference of 2 cubes, which is x minus y, and then you have x, you square this one, this times that times negative, which is plus xy plus y squared. So which means it is 2x minus 3. You square this one, which is 4x squared. Then you multiply these by that, you multiply by negative, it becomes plus 6x plus 9, which is exactly this. So it's going to cancel out, making it much easier. Right, so when you get to this point, this one cancels out, and now we just have the derivative with respect to x. That's what the notation means. D subscript x is the derivative with respect to x, and you find the derivative. Derivative of the 2x is going to be just 2. The derivative of minus 3 is a constant. A number has derivative 0. The answer becomes 2. Okay, I just commented because it looked so junky. Okay, but yeah, it's easy. All right, next question. All right, you told me it's something.
Question 5D, sir.
Okay, 5D, right? Let's see. I'm moving towards it. Okay. Okay, explain why the formula given in that does not work after the 11th stop. Okay, the formula given in 5C, this one. If it is given that this one, if it is given that Tn is this, determine the maximum number of passengers on the bus. Okay. It's a creative question from the examiner. And then in 5D, they are saying, explain why the formula does not work after the 11th stop. Okay, if it doesn't work after the 11th stop, you need to ask, what is it for? This one determines the maximum number of passengers on the bus. Write down the number of passengers on the bus after the 5th stop. Okay. Now, obviously, we're going to analyze this together, but something I'm going to mention about 5. About 5 D. Okay, yeah, so if they say does it work, so there's negativity, so there might be a negative number, and we're trying to count positive things with these formulas here. So explain why it doesn't work after 11th stop. So you can let n be 12, which is after the 11th stop.
So why are we using the number that's after the 11th stop?
Because we want to show, that's a good question, because we want to show that it does not work after the 11th stop.
Oh, okay. So I didn't read the question.
Or I get your point. Yeah, so it's after, so you can choose any number. The first one would be like 12. After 11th stop, and show that it's going to give a problem. But obviously, the formula itself is minus 2n squared plus 24 minus 20. So you're going to have that. Okay, just pick my writing tool. 1 minute. I want to pick my writing pen because now sometimes this does not become clear in terms of where I'm pointing and what I'm writing. I need to get from the downloads, please. Right, so you have this. Okay, right. I have my highlighter. Yeah, okay. And then I have my pen, and then I can continue. Right, so I was then saying, obviously, the formula doesn't work. Normally, these formulas must give us positive things. But now sometimes they give us negative things and which do not make sense in real life. Like if you had to say, determine the maximum number of passengers. So if you want to find the number of passengers, the number of people, number of things, which cannot be negative. So it gives a hint that if they say it doesn't work, doesn't give the number of the passengers, so it might be giving negative numbers. So that becomes what really happens. So at this point, you'd have to define T12, Tn, which is minus 2n squared plus 24n minus 20. So it doesn't work after the 11th stop, which means T12 is minus 2 into 12 squared plus 24 times 12 minus 20, which means this. Okay, if you add everything here, you'd get minus 20. Because now, if this is the number of passengers, we can't say the passengers are minus 20. So obviously, therefore, this one is actually an invalid due to negative answer. Okay, so it is invalid because the answer is what? Is negative, and we want to find the number of passengers. And we can't have a negative number of passengers. That's one thing. Okay. Obviously, there'll be a couple of ways to look at this question. Or alternatively, somebody can say, because we want this formula determines the number of passengers, we can say we want to investigate this formula. Right, so to investigate this formula here, you can try to solve this formula. Yeah, but it's going to take a lot of effort. You divide through by the -2, which means you have n squared minus 12n plus 10 is less or equal to 0. Okay, if you find b squared is 144 minus 40. Okay, it's going to have some decimal solutions, but you realize therefore that at this point, n is, which are the critical values? The critical values should be n equals 6 plus or minus, if you use a quadratic formula, because you can't easily find the factors of this one. But the quadratic formula is going to give this, which means that you have 0.9 and you have 11.09, and therefore is less or equal to 0. Okay, number of the people, either you have 0 passengers or more than 0 passengers. So if you draw this, then it's going to have a number line like this, or you can look at the graph we are used to for Solving this, it's going to have a minimum vertex because the coefficient of the quadratic term is a positive. So, which means now if you use a quadratic formula to solve for n, you therefore have 6 minus the square root of 26, and then you have 6 plus the square root of 26. So, as a consequence, you then have that you'd have to look at where this is less than or equal to 0. Equal to 0 means you shade here, and then less, you go down. It was greater, you go up. And then now, at this point, you would say, when is this less or equal to 0? Okay, when n is between these things, the critical values. Right. So, which means it is 0, 9 n, which is 11,09. Okay, that will be the n. So the n is going to be exactly in that interval, meaning this formula is only valid up to 11,09, meaning it cannot work after the 11th stop. That would be another way to do this question. We say, okay, to investigate the formula and say it's valid for number of passengers which are either 0 passengers or more than 0 passengers. So when is it valid for what values of n? Is it valid? Is it critical to 0? So it's not going to work after the 11th stop. Or an alternative, as we said, we can pick the 12th stop and substitute and realize that it's going to produce a negative number of passengers. So we can't have negative 20 passengers. And therefore meaning it is invalid. Yeah, any question? Okay. What do you think about it? Um, you think about it. Right. Good. So you think about it and think and see what is best.
Okay, so my next question is on question 6, number A.
Okay, 6A. Let's see the
Yes,
next
sir.
one. Is it this one here?
Yes, sir.
All right, determine the values of x represented on this sketch for which f of x is greater than g of x. Okay, so obviously this one means that f is above g. F is above g. Where is f above g? Right, so f above g would mean that at this point, you can see that this is f and this is g. But here you can see that f is above g. And at this point, you can see that g is below, up to the point of intersection. So the graphs of f and g intersect at point B. Okay, B has the coordinates 3 and 1. So at this point, we have x and y. So x is 3 at this point, but you have that y is 1. Okay. The function f is below, but we're looking for where f of x is strictly above g. Right, when is it above? It is above g here, which means that between between 0, x is 0 here, and x is 3 there. So the function f is above when x is between these things. But obviously at this point, at x equal to 3, it's not above, right? Because we want strict. But at x equal to 3, they're equal. Yeah. But at x equals 0, the function f is indeed above. Okay. So that would actually be the answer there in question 6a. Yeah, this is enough. Between 0 and 3. Because between 0 and 3, the function f is above and g is below. Okay. That sort of becomes the answer. That, in fact, is the answer. No doubt. No doubt. All right. So any question?
So can we do like another question that's like this?
Okay, that's a good question. That compares like greater, less. The There's some other exponentials. Let's see. Okay, the exponentials, did they compare the things here? Show the asymptotes. Yeah, I can look at, I can draw those graphs. Let me see what else they've brought. Okay, so obviously this would be any question on graphs. Right, any question on graphs, just looking. Let's see. All right, ratio. All right, here's an interesting question. So you have these kinds of graphs here. X coordinates. Okay, yeah. Determine the values of x for which f is above g. Okay. In this question, they are looking for where f is greater or equal. So it's not just above, but it can also be equal. So it has this equality condition as well, greater or equal to g. But we are looking at where x is actually an element of the interval from minus infinity to 0. So negative part, non-positive part. F above g. If f of x above g. So you have this here, but we must only look at the case where you have minus infinity to 0, not other parts. So let's analyze this question. Okay, the graph of f cuts the x-axis at 1/2. Here is the graph of f. It touches it at x equal to -3 and cuts the y-axis at 9. But when is f above g? Let's see. Here is f, but here f is below. Now here f is above. So f is above g over here. At this point, f is above g. Okay, we'd have to just deal. So now, for what values of x? Obviously, we need more information. Would be interested in knowing the point of intersection, because then we can know, we can see here that f is above g because g is this one. Okay, but also there is f here and there is g as well. Right, so this is question 9. Okay, let's analyze question 9 carefully. Right, we're looking at question 9. Right, now the f above g part would be, okay, the point of intersection, but also here is f, and also here is g. Um, but we can't go here. We can't go beyond because you must stop at 0. And we stop at x equal to 0. Which means that um, where is f above g? Okay, so here you have up to this point. The function f is above g. So that would mean that from minus infinity to minus 3, f is above g. Up to 3, or okay, now g is above f here. G is above f here. But here now up to this point. So we cut this out. From here up to the x-axis up to x equal to 0, because you must look from minus infinity up to 0. Okay, minus 2 here, which means minus 2 to 0 is the answer. So when would f be above g? Minus in, so we must shade here. F is above g here because g is below. So f is greater equal to g there. Right, so that's the answer.
Sir, can I also just ask, when do you know when to use the round and the square brackets?
Okay, yeah, that's a good question. So obviously the square bracket means that you are speaking about included points. Right, included endpoints. We never include infinity. So like minus infinity, because it's far away, a very large number, we always exclude infinity, always. So yeah, like here we have to exclude infinity up to 3. But now the issue with the 3 here is minus infinity to minus 3. At minus 3, why would we actually, because at minus 3, you potentially have cases where the function itself is potentially asymptotic. In particular, the function g has an asymptote, it's undefined. So because the function is undefined, then you remove the minus 3 because you can't definitely state what's happening at the asymptote. And then they did not draw the asymptote here, these guys who created this question. But from minus 2 to 0, from minus 2 to 0, right, from minus 2 to 0, you can see that one graph is above. And now at minus 2, why do we include minus 2 here? Like I've written minus that, and suddenly I decided to include minus 2 and then even 0. Because the reason is at minus 2, they're equal, and the condition is we must investigate where f is greater or equal to g. Here they're equal. Here they're what? They're equal at minus 2. And then when you get to this point, g is okay. Now at this point, so you can see that 1 is above. So at x equal to 0, they are greater. F is greater than g. So should we include 0? Yes, because it satisfies the condition. And so 0 must be included because at x equal to 0, when x is equal to 0, indeed f is above g. So f is greater than g if and when x equal to 0. Should we include minus 3? No, because at minus 3, there is an asymptote. So one of the functions is undefined. In particular, the function g is potentially asymptotic at, there's an asymptote at -3. An asymptote here. And then there's another asymptote that did not just draw it. Something like that. Because of the asymptote, then the -3 is out. Also in minus infinity is always minus infinity is out. We can't include that. Any question?
No, sir.
So think about it then, and yeah, think about it. Another part of this paper we can discuss, and see, and try to look at something. You can also text me if you have questions on the things, maybe. You can text me on WhatsApp as well. Okay, you can also let me know if you have another question in this paper or another paper. I can open it and we can look at it, you know?
Okay, sir.
Yeah, I can always open another paper. Maybe that you have a question and then I can open that paper and we can discuss the question. And with time, I wouldn't want to frustrate you, but with time, if with time, I was gonna give you like exercises to try, you know? But I can't give you a lot of exercises because I don't want to stress you up. Um, I was gonna give you a full paper, but you see, we don't have that luxury of time. I can't be giving you now a full paper. It's gonna take you 3 hours to finish. It's it's like 10:30 now at night. So you can't have 3 hours from 10. 3 hours would take you to 1:30 in the morning. So yeah. So you can only like do some of the questions that you think are interesting. And then I can ask you some questions. Obviously, I can ask you a lot of questions from the exams, but I feel that it's not wise when you're writing tomorrow. No, it's not
Yes, sir.
fair. Just give you 1 million questions when you're writing tomorrow. I feel it's crazy. It's crazy behavior.
So I just have
Yes.
two more questions.
Okay.
The other one is on C, and it's specifically where it says state its domain.
Okay.
And
See, yeah, see this one.
I think it's question 7.
Okay, let's see. Okay. Question 7, is it above or below? I'm just okay, it's above. Okay. Um, let's check question 7. Let's check question 7. Okay. Let's see now. Question 7. Was I going down or what? I'm still not reaching. Okay. Question 5, this one. Right.
Oh, so we just passed it?
We just passed it, eh?
Yes, sir.
All right. Because it's now that I'm seeing question 7. So, okay.
Yeah, it's question 6, number
Question
C
6.
then.
Okay, that's fine.
Yeah, it's that question.
Yeah. Determine F inverse, the inverse of F in the form that and state its domain. Okay. Inverses are easy to determine. So, how do we find inverses?
So my main question is, how do we get the
Yes,
ranges and the domains of the equations of the graphs?
of the graphs. Okay, yeah.
Yes.
How do you see the domain and the range of a graph? Okay, the domain of a graph is easy. You just have to look at if the function is undefined or not at any given point.
Oh,
So,
so it's like there are restrictions for the graphs.
yes, yeah, the restrictions for the graphs. Okay, the domain restrict. Okay, first for this question, what is f? Because we want to find the inverse of f, we must know f. So what is f? F is this one, right? And f is the square root of kx. So yeah, um, okay. Now this is the function f, which is the square root of kx. And then now, um, f of x is the square root of kx. Okay, obviously we are just looking at the question in the middle. There can be other instances where we can find the value of k. Um, so yeah, okay. Right. If they say determine f inverse, first and foremost, you just write two steps. Okay, the first step is f equals, you write f like this and you write a colon and then it is um like this. So you mean kx. And then the next thing is now you find the inverse. You write inverse. Well, if you write inverse, wherever there is y, you put x. Wherever there is x, you put y. This is already the inverse. You can just make y the subject, but it is the inverse. Okay, we only make y the subject sometimes if it's possible. Sometimes it's not possible. Yeah, but the school ones, but generally functions might not even be possible to make y the subject. In some instances, the thing can be too complicated. Okay, so if you have to determine f inverse in the form y equals something, this is f inverse already. Can we write it in the form y? Yes, we can. Okay, we just to get make y the subject, we must remove the square root. So how to remove the square root? We can just square both sides. So which means x squared, then we have ky and we square like this. Which means x squared is equal to ky. Which means y is equal to 1 over k that is already the inverse. So write it in the form that is y equals 1 over k x squared. Okay, I've not done the whole question. There might be a question that is using a point to find the value of k. So we can know what k is and can substitute straight away. Right, but
So K is 1/3.
it's 1/3, eh?
Yes, sir.
Okay, if I trust that obviously you're right because it's from the above question, but it's not really going to have an effect in helping us get the answer here. Okay, if it's 1/3, it's okay. But state its domain. The inverse is a quadratic. It's like ax squared plus bx plus c. But these terms are zero, so it's ax squared. What is the domain of a quadratic? Okay, to look at the domain, you need to look at, is it undefined somewhere? Like this one is undefined somewhere. 1 over x is undefined, so because it's only defined when x is not zero, this 1 over x function. So this one is always defined. It does not have a square root, so we can say we need positive things, so real roots. It does not have a fraction, so its domain is a function like this. Its domain is just a set of real numbers because it's never undefined. Undefined functions are 1 over x functions or the square root functions. The square root function is only defined, so there's a restriction. This is only defined when x is greater or equal to 0. This one is only defined when x is not 0. So, but this one is only defined when it's defined for everyone, everything, x element of R. Okay. Make sure you understand. Make sure you understand. Okay. So what is the domain? I did not even have note k. It's a quadratic function. Its domain is all real numbers. The parabola, there's no way the parabola can be undefined. It's always defined. How do you see a function that's defined like the parabola is always defined because the graph maybe is like this or like that. It goes all the way to minus infinity. It goes all the way to plus infinity. There's no way it can be undefined, this. Okay, so it's nice and easy. Nice and obvious. Nice and obvious.
So the last question I have is
Yes.
question 8, number A1.
Is it which one?
Question 8, number A1.
Oh, 8A1. Okay. Yeah, 8A1. Let's see. 8A1. Right, this one, A1. Right, explain why the equation does not have any real solutions. Okay, yeah, this is a very interesting one because it does not have a square root, but there is a real thing that they're asking. So it violates some mathematical principles. What does it violate? Because in mathematics, it's already a square. In mathematics, if you take anything, like even if a negative number and you square it, it becomes 4, which is a positive number. So if you square this, it has been made negative, so which is impossible. Well, the reason why this has does not have any real solutions, because in mathematics, the square must be greater or equal to what? 0. But 2x squared minus that means that minus 5 is strictly less than 0. This means that 2x minus 1 is less than 0. It is impossible. There's no way you can square any number and get a negative. You see, it is by dint of that it is the explanation that is quite sufficient to justify the fact that this particular equation does not have at all a real solution. And you don't need to write, because how many marks is the question worth? 1 mark. Explain why the equation does not have any real solutions. Well, the reason is that the square is greater or equal to what? 0. And therefore it can't be negative 5. It can't be. And they've forced it to be negative 5, which can't be the case. It can't be a negative number. And therefore there are no real solutions. There are
Okay,
no
sir.
real, yeah. Any question? So yeah, I don't need to write too many things. The thing you need to write is to say, explain why this does not have any real solutions. Is to say this one is greater or equal to what? 0.
Okay, sir. The next question is number 4.
4.
Number
Question
4 and
4.
5.
Okay.
Yes.
Okay, let's check question 4. Let's see question
So
4.
not question 4, question 8, number A4 and 5.
Okay. Is it question 8?
Yes, sir. The
Okay,
question that
question
was
8, A4, something like that. Okay, let's check.
yeah.
8, 8, is it 8 or what this? Yeah, A4. Right, solve for x in terms of k if this is the case. Then write down the values of k for which the equation has real roots. Okay, they like the real part. So the real part is going to occur when you have the square roots. So obviously we need to solve for x in terms of k if that is the case, which means is 2 that squared equals k. So solve for x in terms of k, that's in right-hand values of k for which the equation has real roots. To solve this one, you need to, there are many ways to do it, but the easiest way, because it's like if they give you x squared equals 4, what is the easiest way to solve this one? Is to take the square root both sides. And then put plus or minus. We're gonna do the same here. So because it's like a square here, we're going to take the square root both sides. The square root both sides, which means 2x minus 1 equals plus or minus the square root of k. Okay, so the square root removes the square, and then we have plus or minus there, which means 2x plus or minus the square root of k. Divide by 2 plus or minus the square root of k divided by 2. So that is the answer. That is the what? The answer. Yeah, solve for x in terms of k. So we are solving for x, but it must be in terms of k. So the answer must involve k. And write down the values of k for which the equation has real roots. Real roots would have to just look at the square root. And the real roots we require that either we take the square root of 0 or something positive. So yeah, write down the values of k. These are the values of k. So whatever is under the square root must be greater or equal to 0 with the square root. So you look, what is under the square root? It's k. And whatever is there must be greater or equal to 0. And that's the answer. Okay.
Yes, so that makes sense. And then so the next question is
Yes.
the following one, number 5.
Okay, number 5. Let's check number 5. Right. Give 3 values of k for which the x-intercepts of these will be real, rational, and unequal. Okay. 3 values of k for which the x-intercepts. So we're looking for the x-intercepts. How do you get x-intercepts? You let y be 0. The minute they mention x-intercepts, you must let y be what? Be 0. And this means wherever there's y, you put 0. Give 3 values of k for which the x-intercepts of y will be real, rational, and unequal. Okay, so 3 values of k for which the x-intercepts. All right, so obviously a couple of ways to think of this one. There are billions of ways. There are billions of ways. Right. Right, there are billions of ways. And now to solve this one here, you might have to you can use a discriminant to be safe. Okay. So right, one way is to say, okay, there are too many ways to solve this question. One way is to look at this one here. Okay, you square this one, 2x, you square it, it becomes 4x squared. 2x times minus 1 is minus 2x times 2 minus 4x plus 1 plus k. So which
So why did
means
you put the 1 and the k in?
in
Oh,
brackets.
it's yeah.
That's a good question. Why did I do that? It's because now I'm writing everything in the form ax squared plus bx plus what? Plus c. Right, so the constants that have nothing to do with x, we keep them together. And then now we can write b squared minus 4ac because we want to deal with the rational unequal real roots, the nature of roots. We call that the nature of roots. So b squared, which is minus 4, squared minus 4a, which is that c, which is 1 plus k. Want to analyze this. So if you square minus 4, you get 16 minus 16k. 16 minus 16 is 0, giving us minus 16 what? K. And therefore, this discriminant is what is under the square root, right? Is what is under the square root. So the square root has, well, x is minus b plus or minus the square root of b squared minus 4ac out of twice a. Okay, b squared under the square root has, well, under the square root we have the delta. So the delta now is minus 16k. Okay, if the delta is minus 16k, then we come to this. 3 values of k, so you must just think of 3 values of k. That will, such that these would actually be real, rational, and unequal. So you want these to be a real number. If k is minus 1, then you have the square root of these, which is the square root of 16, which is what? Which is 4. And then if k is, okay, like you guess minus 1/4. If you divide 16 by 4, you get what? 4, and the square root of 4 is 2.
So does k have to be negative?
Yes, k has to be negative. Why? Because we already have a problem. The problem is that we have minus 16k, and we can't take the square root of a negative number. So we must make sure that the k is negative, so that negative times negative is positive. And then we have a positive under the square root. So we can't say k is 1, because if you choose k to be 1, then minus 16 times 1 is minus 16. So the problem is not sorted out, because what is the problem with this? The problem is that we have a negative under the square root. So what can k be so that we have a positive under the square root? The first one is minus 1. Then we have the square root of 16, which is what? Which is 4. So we want those numbers. So we want these to produce numbers under the square root that have square roots. 16 has a square root, 2 square root is 4. But that means k must be minus 1. But if you choose minus 1/4, then you also have 4 under the square root. The square root of 4 is what? Is 2. If you choose like something else,
Also, so these values that you're substituting into k, they are the three values that they said we
yes, they
must
said
calculate.
we must come up with. So it's just a question of guessing these values. The question is, okay, 16 itself is a perfect square, but if you choose, like, you can say k is minus 1 over 16. It must be negative, because you already have a negative, you want a plus. You can't have this, you can't have a negative under the square root. So you take now minus, minus 1/16, because negative times negative is positive. 16 divided by 16 is 1. The square root of 1 is 1. So you're taking this because these are perfect squares. This 4 is the perfect square, which is 2 squared. 16 is a perfect square because it's 4 squared, and therefore the square root becomes 4, the square root becomes 2, square root becomes 1. Okay. So that becomes the situation.
Okay, so that's all my questions for this question paper then.
All right, so yeah, think about whether you have other questions. Because we do not sleep, we stay awake throughout the night, um, ready to solve any question that comes our way. So yeah. So think about it. Let me know if you have other questions. Right.
Okay, so I'm gonna do a few questions on the 2018 past paper and see if I still need help on them because the questions are similar to what I was asking you.
Okay, that's fine. So you let me know anytime. Anytime I'm available, even at 2 in the morning, I'm available. But obviously, you need to sleep. You need to have sleeping time. You see,
Yes, sir.
you need to sleep because otherwise, then you will daydream. You see, daydreaming is bad. You don't see you see to do mathematics. You need to have a fresh mind so that you don't make like silly mistakes, addition mistakes. Basic things that you could manage, but sometimes the mind is too tired and you're sleepy and you can't. If somebody is sleepy, even basic addition they might just think 2 plus 3 is 2 times 3, something like that. I'm just saying. So yeah, so you let me know. Okay. But I'm available throughout the night until the morning. Okay.
Yes, sir.
Yeah, so keep in touch. So yeah, you let me know then. That's okay.
Okay, sir. Bye.
Okay, thanks. Goodbye, Marang. Goodbye. All the best.
Thank you, sir.
Goodbye, Marang.